Hello, everybody. Welcome to IST 140. I'm, of course, Professor S. You're clearly a student. Let's do some learning. Anyways, before we begin the lecture, let's talk about what's going on here. So, we're in Module 1, right? So that means Introduction to Java, what the heck Java is, what's the background of Java, how does it fit into a computer, all that fun stuff. So, it doesn't seem like that stuff is extremely straightforward. So I'm going to let you read about it. Make sure you read about it and take notes on it. Because I think the thing that makes the most sense is to focus on actually getting into Java now. So I'm going to move on to starting the module 2. I'll start releasing the assignments so you guys have enough time to work on it. But today's lecture is actually going to begin the Java 2 or the module 2. Before I go on to doing that lecture, I want to talk to you about the practice exam. So we have a practice quiz, I should say. Sorry, didn't mean to scare you. We have a practice quiz. The quiz looks like it's going to be on modules 1 and 2, but I want to make sure that we have everything working. And since you'll be doing these quizzes remotely, I want to give you a chance to make sure that your computer works correctly with the with honor lock and everything like that. So make sure that you do the practice quiz and give that a try. The more when that quiz will be, clearly we have to go over module 2 and not all those things are released, so it's not going to be anytime soon. But I just wanted to, or it's not going to be this week. But anyways, yeah, make sure you do the practice problem. We'll go over like everything due at the end of this, at the end of the slides, right before I do some walkthrough. So anyways, without further ado, let's talk about data types. So we've made our first program and we've kind of introduced some data types. But today what we're going to do is start like really getting into what the heck are data types and stuff like that. So our goals for today are assigning values to variables, determining names for variables, and writing comments. Some important important vocabulary is or are declare, initialize, lower camel case, and literal. Okay, I'll be using all those in the lecture today, so make sure you pay attention to the context that they're used so that you can understand it later. Okay, so first of all, you know when we've done the println function, we've had like 8, and I had like 8 also with a variable, but we're gonna get kind of into that. But let's just focus on that literal value of 8. So there was like 2 different ways that it appeared. Do you remember? Like there was like, or maybe it wasn't just 8. Maybe I did like a 3 or a 2 or something like that. But when it was in quotes, it was a different color than when it was all by itself. That's because when it's in quotes, it's a string. And when it's not, it's a numeric variable or a numeric data type, specifically in this case, an int. So as far as like different values that we're going to be looking at, today we're going to be just looking at 3: strings, ints, and doubles. So strings, and there's going to be more to come. So don't worry, there's more. But I think this is a solid introduction. So strings, those are things that have a bunch of characters together, grouped together with quotes. Okay, so you know it's a string because it's that quote. Integers and doubles, those are both numeric types. Integers are, or ints are integers, so things that don't have that decimal point. Doubles have that point. It's referred to as a floating point. So examples of that are like 9.2, 2.0, negative 0.5, and then the other one is 1.2 times 10 to the negative 10 is what that ends up being. But all those are examples of floating point numbers. The idea is like you have a number with a decimal that's like kind of floating around sort of thing. I mean, like it's in a specific spot, but that's what it's called. Now, you may be wondering, why is it called a double? Why not call it something else? The idea was, it's like, if you can remember, this was back in the, Java was made back in the 90s where space was more expensive than it is now. So like every variable like size mattered. I mean, like it's crazy. So back then, I believe it was around the time that Bill Gates said that uh, the only amount of space that you'll need on your computer is 1 gig. Um, which is funny because, like, as the time that this is recording, all your computers, the smallest probably hard drive or solid state drive that you have is probably 250 of those gigabytes. Um, so, like I said, space is different than it was back then. So, um, the original floating point number is a float. Um, and then there was also a double, because sometimes a float wasn't the amount of space needed for a float wasn't enough, so they came up with something that was twice as much, and that's called a double, and it's double the amount of space. Now we're not going to be using floats because, I mean, like, we'll be using the floating point data type, the double, but we're not going to be using floats because space is much more cheaper and might as well. So that's why we're doing it. That's why we're not using the floats, the float data type. But that's also like one of the reasons why I'm also bringing that up is not just because it's confusing. Why is it ints and doubles and not something else? But it's also to help hint that there are different numeric data types or different data types available, and we'll get into more of them later. But before we do, let's kind of get into, like, what the heck is a variable. See, the thing is in math, a variable usually means something that's ambiguous, something unknown and changing. And when you're programming, those variables might be ambiguous or unknown, and they could be changing. But it's really in Java, it's really more of a placeholder for some sort of value. Right. So it's like it's saying, like, it's kind of a promise that there's going to be a value in it, sort of thing. Kind of think of it more like a container of something. In Java, it's actually more of a location, but I digress. The way that I want you to kind of conceptually think of it is as a container, and a container that specifically holds a certain type of thing. And so, like, for instance, to the right, that thing is a vase, and vases hold flowers, right? So the idea is like, when we declare this variable as a vase, it's meant to hold flowers. It doesn't hold anything else. It's just to hold flowers. So when we declare something, it states that we're naming it. We're saying this vase or whatever, brown vase or something. And we're saying the data type. That is, like, in a sense, what it's going to be holding. And then on that same line, or maybe a different line, we initialize. And what initializing does is assign a value to that variable for the first time. It's that initial value, hence initializing. So it's putting that value to that variable. Okay. Now, we talked about there's different data types, and, like, something to kind of think about is that we have literals, and what those are the values that we assign to the variable. So let's say we have these two variables. We have a shoebox and we have a vase. And so what we're going to put in those is appropriate to the literals assigned are of that data type. So, like, the vase holds flowers, so the flower is going to go to the vase, and the shoe is going to go to the shoebox. So the idea is like, we assign these literal values, and those literals are of that specific data type, and those data types of those literals do matter. If you think back to a few slides ago, when we had inside those parentheses where it was the 8, there was the 8 in the quotes and the 8 all by itself. It was different colors because Java treats them differently. One is a numeric value, the other is a string. And so those are different literals. They're different values of that data type, and that's what a literal is. Now, when you're coming up with variables, there's a few rules. We'll go over names, okay? So first of all, variables should be descriptive. You should avoid single character variables. There's a time and a place for single character variable names. But in this, what we're doing in the beginning is not one of them. The idea is like you want to be able to see the variable and know how it's being used. And when you have a single variable letter or a single letter or single character variable name, it's not very helpful. Like, what does X mean? What does Y mean? What does any of those mean, right? So that's why we use like in the first variable that I made, it was num, right? Number isn't super descriptive, but it is more descriptive than X or Y or T or whatever, right? So because you see it and you say num and like that's a number, right? So you know it wouldn't be likely to be a string, it wouldn't be a character, it's a number, right? All right, so anyways, number conventions, I have the first one up. So the first character of a variable can be a letter or an underscore. We're not going to do the underscore thing. It's just, I'm just stating that to be specific. Don't use underscore to begin a variable. It just makes things confusing, but Java does allow it. The remaining can be letters, numbers, and underscores. So what does this mean? This means you can't start with a 4, a 5, or whatever, unless you spell it out. Another thing you can't do is use reserved words. So that means like int or class or anything that we've seen so far. So you can't use reserved words. That's not something unique to Java, but something worth noting. Other thing is, it's like you should write things in camel case. We'll get some examples in like a slide soon, but it should be written in camel case because the idea is like sometimes you want a variable that has multiple words and you need to put them together because the idea is if you don't want spaces, hence why we use camel case. Here's an example. So we have like good num, like we want that to be a variable, but there's a space in there. So Java would think that that's two variables. So one thing that we could do is make it in camel case. So that means we remove the space and the first letter of the second word is capitalized. That's why it's good num right over there, right? So really the big takeaway for naming your variables is that it should be descriptive and it should be camel case. Descriptive is going to be hard for some of our very first programs, but it's a good habit to work towards, okay? All right, so here we're going to declare and initialize doubles and ints. We have the int variable num of cars, which we're assigning the value 12. We have the double, which is class average, which we're assigning 0.89, okay? So notice that these are lowercase. Case matters for these data types because it's indicating these type of objects. And then for the variables, notice that it's all lowercase except for the first letter of the second or the non-first words, right? So those are all uppercase to kind of indicate that that's a new word. Now, if you notice that the first letter of the first word is not uppercase, so this is considered lower camel case. It's to help with variables and methods. We use those for that lower camel case. We use upper camel case for class names. Okay, we'll get into that's like the names of our programs and stuff like that. Anyways, here's some examples of how we might try to convert these names of variables into variables, such as number of cars. We could write that as num of cars, right? So we don't really need to do all number. We could, but I mean, the idea is like we want this to be very readable. That's like one of the first things. That's one of the reasons why we have that camel case to help indicate the spacings without needing the spaces, but also by removing that BER from number, it's abbreviating it, making it kind of a quicker read, more efficient use of the person reading its time. Here's another example. We have class average. I just put them together in capital A. For weighted average, I did weight AVG. Now, could I spell out average and do weighted? Sure. But the important thing is that it's that camel case. Here is first name. There you go. I think you get the point. Anyways, with assignments, once a variable is initialized, the value can change. You can't change the data type. So like once you, like for instance, the code here, we have int num is equal to 5. And in this program, we can't change the data type of num. We can't change it to a double. We can't change it to a string. We can't change it to a float, whatever. It's an int forever. What's not forever in this specific case is the value. So notice int num equals 5, and then I have num equals num plus 6. So we initially store the value for 5 for num, and then in the next line what we say is, all right, whatever the value is for num, add 6 to it and store that to num. Okay, so then if you think about what is the value of num, it would be 11, right? Because 5 plus 6 is 11. So if you did put this in Java and then did print ln num, it would say 11. All right, so something to kind of think about is that equality works very similar in math that it does in Java. But like one of the things that we could say is like when we say in math, x equals 5 and 5 equals x, saying the same thing. In Java, it's not, because when we use that single equation, that single equal sign, we're assigning a value. So when we say x equals 5, we're assigning 5 to x. When we write 5 equals x, we're assigning the value of x to 5, and that just confuses Java. So don't confuse Java. Always put the variable to the left and the assignment to the right. Okay. Notice, I mean, like in my example here, when num equals num plus 6, we have a variable on both sides, but the assignment, the thing that we're assigning the value is on the left, and what we're assigning to it is on the right. Okay. And I realize I'm kind of mirrored, but you get the point. Anyways, there's one other thing that we can do is constant. These are different things. The thing is when we do final before the int, and we have, like in this case, carton of eggs, it's customary for constants to be written in this all capital things to kind of indicate that it is a constant. And we say that it's constant by saying final at the beginning and doing all caps. So with these variables, like in this case, a carton of eggs is 12, it's permanently assigning in the program 12. So we can't later in the program change the value of carton of eggs to 18 or 24, so anything that we want. It's going to always be 12. So that way that anytime that somebody like messes around with that variable, they know that they can't and they wouldn't be able to. Okay. We'll go over the example of that in the walkthrough in just a second. But the one other thing that I want to talk about that I promised I would is comments. So the idea is like in program, when we're doing these Java programs, we have to think about the reader, whether it's us, like as your case, whether it's future you or the teaching team grading whatever you're doing. You want those people to be able to read it, both future you and the teaching team. You don't want to have to figure it out all out. Two ways that we have to do that we're introducing in this lecture is one, using descriptive name for variables. That does a lot. Also, another thing is comments. Comments help explain different things that are going on. What comments are sections of code that the compiler just ignores. And we can either do like a line or a little bit of a block. So notice here we have, this is just for a single line. That first one is just like hash hash, and then anything to the left of it is just for that line. That next line down, that's free game. But to the right of it on that line, that's, sorry, and I realize that it's this way for you. That is going to be ignored by the compiler. I'll show you an example of that. The next one, not used maybe as much, but this is more for a block. And so notice that's a line with an asterisk, and then it's punctuated with an asterisk with a line. So the dash or whatever you want to call it. The idea is like it knows that that's from in between those symbols to ignore anything that's in there. So you could do multiple lines of a comment to explain what the heck you're doing. So the idea is like comments help give you a platform for communicating to the reader what's going on without it actually interfering with the code. Okay. Anyways, before I get into the walkthrough, some things to remember. Do the practice quiz, make sure you do the Zybooks, and make sure you do the program assignments for module 1. It's not due for, those last two aren't due for next class. And technically the practice quiz isn't due for next class, but I would encourage you to try to do it before next class so that you can get help in class with it. Anyways, make sure you're working on those. Let's do a walkthrough and see like some of these variable assignments where you can see the declaring and initializing in action. Okay, let's go into IntelliJ. All right, so here I am in IntelliJ. I know this is like from the last walkthrough that I did, but I kind of want to walk through again, creating a new project and that sort of thing to help you kind of stay organized as you're doing stuff. So anyways, what we do is you go into File, Close Project, and so then you see my lovely part of my screen. Anyways, here's what the thing looks like. I want to create a new project. I like to create a new project for each week because, I don't know, it helps me stay organized if I want to revisit things that I did from the last thing. So anyways, week 02, I want Java, IntelliJ, I have my JDK, and I always leave this unchecked here, the sample code, because I like to start from scratch. So I create, and there we go. Let's see, then I go into the SRC, and I'm going to do new Java class, and I'm going to call this capital VARS. The idea is that this is a class name. This is the name of the program as far as we're concerned. This should be upper camel case. So I'm going to do enter, and there it is. Notice that it says public class vars. There it is. Notice that it's upper camel case. Now, Java will let you do lowercase, and it's done it before, but I'm just saying usual naming conventions require the public class to be upper camel case. All right, so anyways, we do our main method, which is public static void main string, those things, args, and then we put that in. And so now let's do an ints and doubles. So we have int num1 is, I don't know, 8. And double num2, 2 is 7. Or let's do 7.2. There we go. Got to do capital system. And we'll just do the sum of num1 and num2. Num1 plus num2. And actually, we can even go further and say, let's say we want to say on the same line, the sum of the two numbers is this. There we go. And so then we do a plus. But if we do this, look what happens. So when we run it, notice that it says the sum is 87.2. If you add 8 and 7.2 together, you're not going to get 87.2. That should be 15.2, right? But the thing is it's saying, like, notice that we have this plus with the string. And so remember in like the walkthrough, it's concatenating, right? You want to see how we sidestep this so it actually does the sum? So one thing that we could do is I'll show you one thing that okay. The immediate thing that we could do is just do an additional parentheses in here. And so notice that when we have that additional parentheses, we run it and it says 15.2. But probably even the better part is to take our sum. I'm going to cut it and get rid of this. And I'm going to put in here sum, right? And it's red because it's not declared or anything. So I'm going to do double, and this is sum. And then on the next line, what I'm going to do is I'm going to say sum equals num1 plus num2. All right, so let's kind of see what happens when this works. And there goes. The sum of the two numbers is 15.2. All right, so let's kind of review what's going on. So notice that on line 3 and 4, we're declaring and initializing those values for those variables. On number 5, we're just declaring the variable sum as a double. And then on line 6, we're initializing it with the actual sum of num1 and num2. Okay, so we don't have to declare and initialize on the same line. But if you notice, like for what we're doing here, it's easier to read these when we declare and initialize on the same line. Now, we could also like change some of the values. Like for some reason, let's say I wanted num1 to be 3. So now notice that we have num1 is 8, num2 is 7.2, and then now here I'm changing, I say num1 is 3. This is grayed out, probably because it's never used. And saying, like, kind of trying to point out the efficiency of changing it. But so then now the sum is going to be 3 plus 7.2, which would be 10.2. So something that can be done. Or what we could do is we could do num1 minus 5, and that would be also 3, right? But here, notice it's keeping the same color because we're still changing num1, but it's still using this value here. So it's still, as far as it's concerned, an efficient use of space, but it will still get this same value because it says, all right, num1 is 8, num2 is 7.2, and num1 is whatever num1 was minus 5. So 8 minus 5 is 3. So now its new value that for num1 is 3. And so now it takes 3 plus 7.2, which is 10.2. Okay. Now, we also had strings. So let's kind of get into that. So if we do string word, and I say that is hello, there we go. But notice that the string is in red, and then also when we compile it, it has a problem because it says it's having a problem with this class string. The idea is like string has to be capitalized. There's like a more complex reason why. That's going to be just easier just to say, we'll kind of get to that later, or it's just easier not to worry about it now. It's one of those difficult things with Java. I'm sorry. But anyways, notice that we have it here and notice that it's fine. It's like, okay, whatever. And it's the word here, the string word is, or the variable word is gray because it's not being used. So we could just say system out println word. And so now it is. And so now it's that's going to do hello on the next line. Right. And it's certainly strings aren't required to be just one word. You can add spaces. It's just, you could put whatever the heck you want in there. And as long as it's in those quotes, it's still considered a string. So what if you want to do quotes as characters? We'll worry about that later. The important thing is, like, for the most part, as long as there's no quotes, it will see that open quote and say, all right, everything here to the right of it till we see that next quote is a string. And that will, like, to do the quote inside of it as a string is something slightly different, but yeah, it's just the quote by itself. Anyways, let's see. Another thing is like I said, with this declaring and initializing, we could just do this on the same line. Kind of makes more sense to have it like this, right? It's easier to read, don't you think? And we could do comments here. Finds the sum of the two numbers. But notice that this sum of the two numbers is like, the compiler doesn't do anything about it. If we didn't have those two lines there, notice it's all red because it thinks it sees variables that it's supposed to do stuff with. So like having that comment makes it a little easier. Anyways, I think that is good for now. We'll get more into declaring and stuff like that next class. But for now, I think that's good. Anyways, I'll see you all later. Bye. Hey everyone, hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.